Okay, so what we're going to be looking at now is solar engineering, and ways to store energy. Why do we have to look at that when we look at solar? Well, one of the problems with solar energy is that solar, of course, peaks when the sun is out. So there's no solar power at night. And also, the peak is in the middle of the day when the sun is highest in the sky. Unfortunately, that's not how mostly we use America. We use energy in America. Our energy uses are this solid black light. We tend to use a lot early in the day, and then we use it later at night because we've got all those lights on it stuff. And our energy use doesn't really match up with our solar panels. So about the only thing part of it that does would be air conditioning. So air conditioning does line up. It's usually needed the most during the hottest part of the day. So that means we have to be able to store energy and manage energy. So of course, one of the ways to store energy is in batteries. And so batteries are very big. And so here are some trucks full of battery packs that you can just drive up and store energy. So next to your wind generator or whatever. Um, so some places are investing heavily in batteries. Another way to store energy is what's called pumped hydro. So pumped hydro is where excess energy during the day from a um, solar panels might pump water up into a reservoir, and then at night that energy, the water would be allowed to flow down and run a turbine, and so you would get electricity back. So that's one way to store energy. And you can store wind power when there's wind is blowing fast. You can store that energy and then let the water run and create electricity when the wind has died down. So pumped hydro is a pretty exciting way of doing it. Um, so Hoover Dam, um, they're actually thinking of that as being part of a pumped hydro system. So water might be pumped back up out of the river, back behind the dam, because there are a lot of solar uh, generation areas near there, uh, and wind power, and so you could use that to pump energy up, pump water up behind the dam. Compressed air storage is another way to store energy. So compressors use excess electricity, to pump air down into um, a storage area, which might be a natural cave or a salt mine, or a geological trap where there's permeable rock layers. And or you can build caves, special caves. But the idea is that you can pump air, and usually there's some water involved too. It's an air and water possibility here at Hydro Store. And then the compressed air will drive generators later when you need the energy. Well, what else could you preserve? You could preserve energy as potential energy. So that's sort of what you're doing with pumped hydro. You're raising up water. What if you raised up just like blocks of concrete or something? So this tower here could be built over and over again. Blocks could be raised up from the ground, so it could go up, and then later they could be released, and as they pull on their cables, they would generate electricity. Like when you yank the string on some small things to make them go, right? And whizzing. You could pull the string and generate electricity. Okay, solar power is one of our most reliable ways to generate electricity. It's huge, it's booming right now. I was just reading that farmers, rather than leaving their fields fallow, um, as they would rather put solar panels all over them. So anyway, so yeah, so there's all sorts of ways to um, fit solar power into our country. And so there are two basic ways. Solar voltaics are solar panels, but then there's solar thermal technology also, which involves mirrors. And the solar thermal technology is also called CSP, concentrated solar power. So solar panels takes advantage of a rule of physics where certain materials, if you shine light on them, they produce electricity. So you're turning light into electricity. And solar panels have an efficiency of at least 10%. Newer ones are closer to 15. Concentrated solar thermal power is about 20%. Now, the energy from sunlight is about 1 kilowatt per square meter. So if your desk is about 1 square meter, sunlight shining on it would be about 1,000 watts of power, 1,000 joules per second. However, if your solar panel was only 10%, then that means you would only get 100 watts. So you could run 100-watt light bulb. But of course, everybody runs LED bulbs nowadays, right? So anyway, so the idea is you could, yeah, with one solar panel, you could run a 100-watt light bulb or so. Anyway, solar panels should be everywhere. So they should be on rooftops. And they keep the rooftop cool while they generate electricity. Solar panels can be in large farms. So every 7 acres generates about 1 megawatt of electricity. So here is Disney trying to offset their carbon footprint. And so there are farms, like some places in like Georgia and stuff. You're not growing tobacco anymore. The soil is shot. Cover it with solar panels. You can get more money that way. But you don't have to cover good farmland, but sometimes it does. But sometimes you can keep growing things underneath. This is actually in Wisconsin at Lake Geneva. And this is a investment. So you can have investors who buy into the solar farm. And you can see they're growing sunflowers underneath. Chicago actually has one of the largest urban solar power plants. And so what they did was an old parking lot and factory site that had where they built train cars, the Pullman train cars, now has 32,000 solar voltaic panels, and it can power 1,500 homes. So empty lots can be used for this. Unused parking lots, old factory sites can be made covered with solar panels. You can also have them on the roof, and they can look like the ones that I showed before, or sometimes you can have tiles. So Tesla started investing in these tiles that look like regular roofing tiles. They are, of course, about 3 times more expensive than regular tiles, but they generate electricity and they look beautiful. Okay, now the other way to get solar energy turned into electricity is concentrated solar power. And so this site is in the Mojave Desert. And these are mirrors on poles. Those are called heliostats. They shine light at a solar receiver, which has a fluid in it, usually a salt water sort of thing. And so light shines on that, heats it up, turns it into steam. And the steam generates electricity. And overnight, when there's no sun shining, they store some of the hot water so that they can start it up the next day with hot water already. So heliostats shine light. Electricity is created by a steam turbine, and then it goes off to the grid or it gets stored. And if you ever fly into Los Angeles, it's pretty exciting. You'll start to see these 3 bright things about where Las Vegas is. And you can see them from space. I've seen them anyway from airplanes. And they're glowing like the sun because what it is solar is the heliostat shining light onto these towers, and it gets brilliantly hot. And it's amazing to see. And then at night, when you drive by, then they have just red blinking lines. They're not doing much. Okay, so anyway, so this one has 173,000 heliostats. Anyway, so India and China are installing a lot of these. But solar panels, another place to put them, is on top of reservoirs. And so in Australia, in India, in Australia, oh, that was Australia, in America, in California, they're putting floating solar panels. And the amazing thing about these is it doesn't displace farmland and it cools the water, which leads to less evaporation. It also cools the solar panels so that they're more efficient, so 50% increase in efficiency. And the thing is, California being covered with canals, you could cover them with solar panels. And that's what they're doing in India right now, too, is they're covering some of their canals with solar panels. Now, Lake Mead could also be covered with solar panels, and it could generate more electricity than Hoover Dam. And it would reduce the water loss, which right now, one of the problems is that water is evaporating, and you could stop some of that. Okay, so anyway, so that's another exciting possibility. Let's see, this is in India. So they have their canals being covered with solar panels in some places. And this can bring electricity to the small villages along the canal route. So you don't have to gather it all into the big city. It can go right to the towns that are along the way. Anyway, so solar panels everywhere is a possibility. You can buy a table to charge things. You can use the sun to cook a pizza, so solar cookers. Anyway, so there are lots and lots of ideas. In India, there's a college called the Barefoot College, which accepts students from many countries, and they're training grandmothers because they found out grandmothers are steady and won't run off to the city to find a job with their new skills. They train them to become solar engineers. They go back to their villages and they help electrify them. And so it's amazing. They're in India. They've sent them back to Africa. And so it's an amazing program. Yeah. Roads didn't work out too well. They'd get dirty. Okay, but solar power, it's everywhere. So anyway, now in the United States, what's called the solar constant um, is we receive only 13% of that energy we were talking about earlier, the 1,000 watts. So it's about 180 watts per meter squared. That's on average. But some parts of the United States receive more. So you can see that, of course, a good place to put your concentrated solar power would be in the Southwest. And the idea is that if we put CSP, a lot of it in the Southwest, we could generate 7,000 gigawatts of capacity. That would be about 7 times the current US energy capacity. So it's not that we don't need to cut down on our energy use. We do right now. But the problem isn't that we're using too much energy. We're just using too much of the wrong kind of energy. Someday, hopefully, we'll be free to use as much as we want because we'll have enough solar panels to provide the energy we need. And it's available. So no fossil fuels, let's go for solar. Now, that doesn't mean that other places shouldn't have solar. Like Illinois here is pretty green, which means that it's not got a lot of sunlight. And some places have a lot less, like Washington State. But what they found out was that sometimes solar panels can be just as useful in those areas because not all in hot areas, the energy almost all goes to air conditioning. Whereas in those areas, the energy goes for other useful things. So they don't have to have air conditioning on all the time. Okay, so works there too. Now, solar panel worldwide, if you look at this, where's the best place to put the solar panels? The concentrated solar power in Africa, of course. So Africa, they're in that deserty area, which is right along the equator. And the idea is that if we use concentrated solar power and solar panels, an area 200 by 200 miles would provide all the energy the world needs. So here we've got lots of scorpions and sand. Would most of us say, yeah, let's take 200 miles of it by 200 and make it into um, all the electricity we need for the world? Okay, cool, huh? Yeah, but we don't actually need that much right there because, we've got plenty of sunshine in the United States and Mexico and South America. So we don't need to provide energy there. They've got plenty of solar, of light in China and stuff. We don't need to help them. But the European Union, which is a cold place, is looking over here and saying, hey, we would like some of your sunshine. So they would need 87 by 87 square would work for them. The Middle East and North Africa would need only about 38 by 38. So we could wire up this place, and South Africa has plenty of energy down there, so they can do it themselves. But the idea is that, yeah, with a lot of help, places that have more sunshine can give that energy to places with less. And so it wouldn't all be concentrated solar power. It would also be wind power, and it could be hydropower, and it could be biomass, so wood. And anyway, so there are lots of different ways to go green. Um, but yeah, people are thinking about it. Now, is that the only place to get energy? No. What about volcanoes, right? Geothermal energy. The heat from the ground is going to provide the energy. So it's in Iceland, it provides 85% of their energy. They use basically no fossil fuels in Iceland. But it is site specific. You have to have someplace near a volcano, basically. Do we have those in the United States? Sure, we've got lots of geothermal sites. So the reds and the orange here would be great places to have geothermal energy. And so the idea, what they do in Hawaii also is like Iceland. You drill a hole down, you crack the ground a bit, you have a second hole, you start pumping water down, it comes back as steam, and you've got yourself generating electricity using no fossil fuels, just the heat of the earth. So yeah, so in Hawaii, they use the heat. But the Yellowstone area has lots of heat also. Um, Okay, tidal wave power. Tides happen 4 times a day. You've got low tide, high tide, water going in and out. Can you use those waves? And the idea is yes, you probably can. So we might be able to turn that into electricity. Or there are generators like this that can be put into rivers and they generate electricity. And so someplace that has extreme tides, like the Bay of Fundy, might be a great place to put tidal generators. Now, biofuels is where you take crops and turn them into fuels. And that is actually an energy waster, as you probably heard. It takes up a lot more energy than it's worth. But the thing is, it does produce a fuel, which is easy to store and easy to put inside the tank of a car. So people are still going to think that we're going to need this for a while. But there's a lot better things we can use than just corn. Okay, there are other materials we can use that collect sunlight, turn it into mass that can be burned. And even algae. Algae can be taught to produce oils that can rival corn. So actually, algae is about 3 times sugarcane, which sometimes people burn sugarcane to generate electricity. Okay, but we still are going to need to store this stuff. So electricity is great for being transmitted across the country. Fuels are good for storage. hydrogen is not a source, but it can be used to store energy. So the way that works is you could take your solar panel or something and hook it up to electrodes that you put in water. And they break down the water into hydrogen and oxygen. And you collect the hydrogen, you let the oxygen go into the air. You collect the hydrogen, and then later, when you want to make energy, you can burn it or use it in what's called a fuel cell. So it's a way of storing energy. And there is a great deal of promise in this idea of storing energy as hydrogen. And now, not all hydrogen is made in the very best way, which would be what's called green hydrogen, where it is produced using renewable energy. But there's also some that's made from methane. That releases greenhouse gases. That doesn't sound too good. So there's green, gray, blue, and then there's energy released using nuclear power. Some have carbon emissions, some don't. So the nuclear one does not. But the idea is that they're actually seeing a huge interest in this. And so there may be like 25 gigawatts of green hydrogen production by 2026. And that would have a huge impact on industry and transport. Green hydrogen could provide 25% of the world's energy needs. And that was from Forbes. So again, financial magazine telling people to invest in green hydrogen. So anyway, so this is, again, something that we're ready to go for. Now, how can you get the energy out? What's a fuel cell? Well, a fuel cell is where you put hydrogen into a special device that has catalysts that allow hydrogen to flow across. When it flows across, then it actually generates electricity. And it flows across because it's trying to get to the oxygens where it joins together and creates water. So you get electricity out and you get water out when you put hydrogen in. And the thing is, this is something small enough that can be part of a car. So this is a hydrogen fueled car. It's got hydrogen tanks and it generates electricity. So it's an electric car like a Tesla or something, except instead of running off a battery, it runs off the hydrogen in its tank. So these are all hydrogen powered cars and buses. Okay, and the cool thing is you have no emissions except water, so you can drink it. And so someday, maybe you'll be able to make hydrogen in your own garage and from your solar panels, and that would be your fuel. You store it, and that would go into your tank, and then you could drive away. Okay, or just, of course, an electric car would probably be simpler. But hydrogen is still going to be a valuable storage device because it doesn't involve any nasty chemicals for the fuel. Okay, so now the problem is it takes time to create the infrastructure for hydrogen. So if you're actually going to have it as fuels, then you need to have a gas station for it, and therefore you have to have enough cars in that area that are going to actually use it to make the gas station have some profit. So it's in LA, but it has to spread, and it's going to take a while for cars to be able to use it. But it will probably still be able to use for storage long before most of the United States switches to hydrogen-powered car. Probably will be driving Teslas. Okay, so that's the end of this section. The last section is going to be about some of the things that you can do to help fix the situation. Okay, so we're gonna, oops, nope, not that. Okay.